Offshore windenergie biedt Nederland grote economische kansen. Het potentieel van de segmenten waar Nederland nu wereldwijd al sterk in is, bedraagt enkele miljarden toegevoegde waarde per jaar. Het thema kabelbescherming binnen de offshore is al zo oud als de eerste transatlantische kabel in 1858. In 1912 ontstond de articulated pipe, waardoor kabels beschermd werden met een gietijzeren mantel. Met de opkomst van offshore windenergie werd er in 1999 een specifiek patent op het beschermen van submarine cables toegekend, gevolgd in 2004 door een alternatief. We praten met Marloes Stuk over het belang van kabelbescherming.
Well, cable protection, what's actually in the name is protect the cable from external influences. We protect cables like data and telecommunication cables and power cables, but also water, sewage lines, and also for offshore wind farms and other renewable sources offshore. Furthermore, what we do with cable protection is avoid an overbend of the cable.
Kabels kunnen door verschillende factoren beschadigen. Zo heb je bijvoorbeeld de otterboards, waarmee over de zeebodem wordt geschraapt, waarbij een kabel geraakt kan worden.
It is very important for offshore wind farms to protect them in order to have a certain profitability. If an offshore wind turbine suffers from cable damage, you will have the need for service and also a possibility to replace the cable. And that comes at a cost. And these costs are really high. We talk about one cable down, roughly €100,000 a day loss. And the further allocation for all the resources to replace a cable or to service a cable comes actually at a very high cost. We had in a current project about €2.8 million to replace a cable, and that's a very difficult expense to compensate. Because in the end, what you see in offshore wind is that we budget upfront and prognose what we can actually earn with an offshore wind farm. But we do not anticipate on all these cable damages and also the service that could come across. That is also a small discrepancy between the procurement stage and also the O&M stage in that respect. Currently, polyurethane is strongly presented as the solution for electrical cables at sea, while the data and telecommunications market sticks to the technique of the articulated pipe. Experience shows that polyurethane has a lower density in seawater and may move under the influence of currents and tides, which eventually affects the cable. For this reason, the product is over-dimensioned in order to meet the requirements for offshore use. This leads to large blocks which are difficult to handle and affect the success of installations at sea. A simple deviation can have the greatest impact on the withdrawal of the cable protection system and can lead to further issues.
De toepassing van PU leidt tot allerlei extra maatregelen om het systeem te stabiliseren door stenen te storten, matrassen gemaakt van beton of autobanden. PU heeft wel beperkingen in bijvoorbeeld strenge winters, want dan kan het product falen. Net als het in de zomer bijdraagt tot oververhitting van de kabels. Dit alles leidt tot kabelbeschadigingen. De kabels moeten daarom ook met regelmaat vervangen worden door duikers, wat in bepaalde gebieden met een sterke stroming serieuze risico's met zich meebrengt. Ook zijn er andere materialen waar de kabelbeschermers van gemaakt kunnen worden.
Metal is a more compact material, more robust and powerful. You need less to achieve more, and that is also anticipated on the environmental conditions that we face in a project. Metal has the advantage that it transfers the heat properly, so it's a heat conductor. And when the area cools down, also the metal cools down. Polyurethane parts are only used, such as corrosion prevention in the systems presented here. And that is actually then the small layer on top of the two metals.
Daarnaast is het van belang dat producten getest worden en gecertificeerd zijn. De markt heeft namelijk het voornemen om vanaf 2018 alleen nog gecertificeerde producten toe te passen in offshore windparken.
Adequate cable protection system actually protects the cable for 25 years product lifetime or even 30, 40 years depending on project specifications. When we talk about inadequate cable protection systems, then it is a serious issue If a cable fails, the cable protection system fails also with it. It cannot be seen apart from each other. There are different scenarios to encounter when talking about cable failures. One is where only a wind turbine is shut down because of a cable failure. But there are also scenarios where the export cable needs service or replacement, and in this case a complete wind farm will be shut down. In conclusion, if cable damages are not taken seriously, offshore wind farms will also have a lower profitability, is not that interesting to invest, and could lead in certain cases even to musea at sea.